Hello there and welcome to the series of videos that's going through the content of A-Level Maths. Here we're looking at logarithms, and so we can answer questions from exercise 14D. Now, writing a logarithm is basically the reverse process of an exponential. So whereas, for example, we have square roots and squared symbols, those two are inverse functions. An exponential and a log function here is the reverse process. So we can use logs to help us solve equations with exponentials in them. And the way it works is like this. If log base a number, so we've got a couple of parts to the log function. We've got a base number and an n number, and this will give us an answer. Now what we do here is we can work out the answer to the power here by doing log of base a of the value n that we are having as our answer in our exponential function. So let's show an example here. So 2 to the power of 5 equals 32. We all know that, but how can we write this using logs? Well, in this case here, the base number on the power here is 2. So this is going to be the base number in the log function as well. So the base term matches up here and here. They're both referred to as the base numbers. So in this case here, it's going to be log base 2 of 32. So our answer now is going to be the n value here and here. So it's log base 2 of 32 equals 5. Okay, so 2 is the first number. Okay, and then 32 and the 5 effectively switch positions. Okay, another way of thinking about this is you can undo this by using the 2 to come along and boost up the 5, and you'll get your answer here of 32. Okay, so that's how I think about it when I first learned this topic. It's the 2 that's the base number that's going to come along and bump up the 5 to make the 2 the base number still, but it will have 5 as a power. Let's have a look at another question then. So can you do this one? 10 to the power of 3 equals 1000. Well, the 10 number here, that's the base number. So on the log, 10 is going to be the base number. And we're not going to use 3, we're going to use the thousands, because the 3 and the 10 swap positions. So the base number is 10, so it's log base number 10 of 1000, which gives you an answer of 3. Another example here, 5 to the 4 is 625, so 5 is the base number here, so it's log base number 5 of 625 is equal to 4. So the base number is the base on the power, and it's the base number in the log, and then you swap the 5, and so 4 and the 625 around. In this case here, the 2 is the base number, so it's log base 2 of 1024 equals 10. Okay, so can we find the value of log base 3 of 81? Well, let's think about it. 3 needs to now be the base number, so 3 coming along and pushing up the 4 here, that will give us 3 to the 4, which is equal to 81. We can do fractions as well. We can't do negatives for a reason I'll show you later, but we can do negatives. Now if this equals an x value, it's 4 to the power of something gives you 0.25, and this value here needs to be a minus 1 because 4 to the power of minus 1 gives you 0.25. And a good rule in general is that if you're doing log of a number in between 0 and 1, you're going to get a negative answer because that's how you get answers as fractions when you do exponential functions. Okay. So what we can do now is we can work out these values here just by playing around with powers. So log to the base 0.5 of 4 equals minus 2. And the reason that is because you can represent 0.5 as a half. 0.5 squared will therefore be 1 over 4. And then just flip that fraction around by negating the power. So you get a minus 2 there. Log a of a to the 5, well that's just going to be the answer 5 because a to the 5 equals a to the 5. Right then, have a go at these questions here. So try to do them without using your calculator. I know there is a calculator mode that can answer this for you, but try and do it without it. Right, okay, let's try now rewriting these answers here as exponentials. So the first thing we do here is it's 2, let's set our answer equal to x for a second. It's 2 to the power of x, 2 is the base number, so 2 is the base number on the indice, of x equals 8. And then from this you can obviously see that x needs to be the number 3. So in this case here, the first answer here is 3. Let's use the same process for the second question here. It's going to be 5 is going to come along and boost the y up. So it's 5 to the power of y equals 25. And we can clearly see here this needs to be a 2. Y is equal to 2 because 5 squared is 25. And the answer to part C here, the 10 needs to come along, boost the z up as a power. 10 is still the base number, and it's going to be an answer of 10 million. So that's 1, 2, 3, 4, 5, 6, 7 zeros. So in this case here, z needs to equal 7. 10 to the power of 7 is 10 million. Right, let's have a look at what we need to do for question 4 here. So let's use that rule of logs where 5 can come and boost up the 4 and we get the value of x. And in this case here it's 625. So here it's 625. For question B here, x will come along and boost the 2 up. So it's 81 equals x to the power of 2. And we can clearly see here that now x needs to be the number 9. So x equals 9. And for part C here, 7 is going to come along and boost the 1 up. So x here is going to equal 7 to the power of 1, which is just equal to 7. So here x is 7. And that's a general rule that if you have log to the base number of a of that number a, you're always going to get the number 1 because a to the power of 1 is still a. Right then, let's do plenty more questions about this on exercise 14D. These are pretty tricky and it does take a little while of getting used to them because they're completely new to you from GCSE maths. So do spend a little bit of time going through them, making sure that you're perfect on them before we move on to exercise 14E and the level of difficulty increases. So it is worth spending some time on these questions. Make sure you persevere through those challenging ones and ask your teacher for help if you need any. Thanks for watching.